Hi there and welcome to this Python video tutorial on loops, specifically the while loop we're going to cover in this tutorial. So it would be helpful if you've already seen the video tutorials on functions and on for loops, because we're going to take it from there. So in the video tutorial on for loops, we looked at this sort of familiar function, circle area from diameter. And what we did, instead of just calculating a single diameter, we just defined a long list of diameters, and we created another function which executes a for loop to go through that list, calculate the area for each diameter in the list, and generate a new list of areas and return that list. Okay, so essentially you want to do something, which you frequently want to do in computer programming, is to do something over and over, particularly in engineering, to a large list of data. You probably get a large list of data, measurements or something, and you want to do a calculation on that over and over, go through that data and do a calculation at each element in a big list. There's another kind of loop which we're going to discuss in this tutorial called a while loop, and this is particularly good if you're generating a list. So if you don't have a list of data but you would like to generate one, especially if you don't know exactly how long you want that list to be. So look, let's imagine there's a scenario that you want to calculate a list. We'll do the same thing with circle areas. So let's say you wanted to calculate a list of circle areas for diameters. Let's say starting at 5 centimeters for diameter and increasing in increments of 5. So you want to calculate it for 5, 10, 15, 20, 25, 30, so on, diameters, until the area reaches some value. Let's say 1,000,000 centimeters squared. Okay, now I don't necessarily know at the beginning of coding this exactly how long that list is going to be. I don't know how long my list of diameters needs to be. I mean, I could work it out, I guess it's kind of trivial, but actually I don't have to, because I can code something called a while loop, and I'm going to just start that to show you how it works. So if I go def circle areas smaller than 1,000,000, let's say. So this function, because we're actually generating a list within the function, we actually don't need to pass anything. It doesn't need any arguments. I think every function we've defined so far in these tutorials have been passed at least one argument. Something's gone in. You can create a function without anything going in. You just leave the brackets empty. It's fairly simple. Generates a list of circle areas with diameters 5, 10, 15, etc. up until the area reaches 1, 2, 3, 4, 5, 6, 1,000,000 centimeters squared. Okay? So what we're going to need here, we're going to need a starting diameter. So we'll start with 5. We need an empty list to store our areas in, just like we did with the for loop. And we also need a starting area. I'm just going to set some area equal to 0. It's probably not clear now why I've done that, but it will become clear shortly. So while loop, I need to use the keyword while. And then it's actually kind of similar to a if and else if type statement that we've covered in one of the previous tutorials. We need now to put a statement, a Boolean statement, which will evaluate as either true or false. And what the while loop will do is it will continuously execute all the code within the loop while that statement is true. Okay. So we want silly typo there. We want the area to be less than 1,000,000 centimeters squared. Okay, and as long as the area is less than 1,000,000 centimeters squared, we want to continue adding areas to our list. And if it goes above 1,000,000 centimeters squared, we want to stop. So at the point we go above, the area becomes greater than 1,000,000 squared, this loop will stop running. Okay. All right, so let's think. So within the loop, the first thing we need to do, of course, is calculate the area of circle for our diameter, which we've done lots and lots of times before. We use this function. So we'll take our variable called area. We've already defined, we've given it a value 0. Now what we're going to do, in fact, I think I'm going to do this slightly differently. Seeing as I've defined, this would be much better. Seeing as I've defined the diameter as 5 already as a starting diameter, I might as well define the area properly instead of defining the 0. We'll define a circle area from diameter, and we'll give it diameter. Okay, so that's just our starting point. We just calculated the first step, if you like. And then within the loop, we want to, let's do this. First thing we want to do is take our area that we've already calculated and add it to this list called area, areas.append area. I'm going to go back through this in a bit more detail in a minute, and I'll explain why I've done this. The order is kind of important here. Now, so then I'm going to recalculate the area for a new diameter. In fact, I'm going to have to do this as well. So I need another step in here. So when we did a for loop, the diameters of our circle, we were reading them out of a list, so they naturally increased at each step of the loop, because each step of the loop we got the diameter out of a list. Here we started off with this initial diameter, but nothing is causing the diameter to increase. We want it to increase by 5 at each step, and we have to explicitly tell it to do that. So I'm going to put in here diameter equals diameter plus 5. Okay? So we start off with a diameter of 5. We calculate the area. We add that area to our list. And then we calculate a new area for a new diameter. We take diameter, we add 5 to itself. And this means that at each step, each time we go through this loop, the value of the variable diameter will increase by 5. Then we need to calculate the circle from the diameter. Okay, if this is all going a bit fast, don't worry, because I'm gonna step through it in a moment. In fact, I'm going to do it now, because outside the loop, when we stop looping, when we reach the end of the loop, we want to get rid of the indent to indicate that this code is now outside of the loop, and we return areas. Okay, I think it's time, we've written enough code now, it's time to run it and see what happens. I'll call the function my areas equals this, circle area smaller than 1,000,000. Okay, save, step, this open ready. So as usual, we step over all these function definitions. We reach a function call, we step in, we go into the function. So a variable is created called diameter in memory, and it's got value 5. A variable called areas is created in memory, and that is a list, an empty list. A variable called area is created, which has 19.6 centimeters squared. So the area of a circle with diameter 5 centimeters squared. 5 centimeters, sorry. The first thing that happens is with the while loop is we apply this test. Is the area less than 1 million? Yes, it is. In which case, go in and execute the code in the loop. So in we go. First thing we do is we take our area that we've got, our existing area 19.6, and we add it to the list. Jolly good. We look in the list, there we go, it's in there. Next thing we do is we change the diameter, we increment the diameter goes up to 10, calculate the area again, and then we go back up to the top of the loop. So that's it. So now the value of area is increased to 78, but it's still the case that 78 is less than 1 million, so it's going to go back into the loop. It will add 78 to the list. If we check our area's list, it's now got 2 elements in it, 19 and 78. And it will add 10 to the diameter, so the diameter's gone up to 15, calculate the new area, and go back up and apply the test. So now we've got diameter equals 15, area equals 176, still, unsurprisingly, less than 1 million. And this just keeps on going. If we keep stepping, we just keep on going. And if you keep an eye on the variable explorer up here, you'll notice each time we go through the loop, the area and the diameter increases, and the list keeps getting longer, and we keep adding numbers to the list. They're starting to get big now. We're over 1,500, but we're still far away from 1 million. We'd have to just keep going and going and going and going and going and going, going and going and going. Okay, so what I'm going to do, I'm not going to step through the whole list like that. What I'm going to do now is just run the code and see what the finished output looks like here in my areas. So if I press run, we now have an object in memory called myAreas, variable name myAreas. It's a list. It's got 225 values in it, and the largest value 225, is 994,019.55. Okay, obviously the next one was over 1 million, so it didn't get put in the list. So there we go. So you see, actually we don't need that. We only need 200 or so diameters increasing at 5 centimeters at a time to get to an area of 1 million. That's because area increases with the square of diameter, of course, so it gets there quite quickly. Of course, we could put 1 million was slightly arbitrary. We could have said 10 million, and then we've got a 713 element list going up. Diameter is increasing all the way up to 10 million. Okay, so that's a nice way of generating a list, a while loop. You have to think a little bit when you're using a while loop. You have to think a little bit about the order in which you do things. So notice that I started off with an initial condition, the first diameter and the first area. And the first thing I did was I appended that area to the list, and then I calculated the new diameter and then the new area. If I'd have done it the other way around, let's just do that. I'll make that go back to 1 million. So if, for example, I'd appended at the end, I'd get some problems. The first thing that would happen is, well, let's just run it and have a look at it. So the first thing that would happen is I'd miss the initial area, wouldn't get written to the list. So I can't remember exactly, it was 19 point something. It was the area of a circle with diameter 5. That's actually now not in the list, because what I've done is I've created it here, and then I've overridden it. I've overwritten it here with a diameter of 10. I've lost that window. Where's it gone? Here it is. I've overwritten it with a diameter of 10, and then I've appended that new area to the list. And the other problem I'm going to have is if I go down to the end of the list, you'll notice my last value in the list is actually over 1 million. because before, every value that got written was the value from the previous step, if that makes any sense. Because there's the first thing we did. We wrote the value to the list at the beginning of the step, and then we calculated the new value at the end of the step. So then when we went round the list to the next step in the list, the value that was written was the value we just calculated at the end of the previous step, rather than the value we calculated within this step. Which means when it got to the end and it calculates an area of 1 million, and then it says, oh, is the area less than 1 million? No, like in this case here. Then the loop just stops and it drops out and nothing gets written, because we took the precaution of always writing the previous area. And it's not very obvious, but that happened just because these were written in a different order. Okay, so calculated new area after we wrote the area. And the area obviously was the value that had been calculated here in the previous step. And that way, when we run it. So that's just you've got to watch out for little things like that. It's easy to introduce little bugs into your code. I think behavior that you weren't quite expecting by not thinking about the order in which these variables get overwritten. And so that is while loops. I think there's another video tutorial or recorded lecture where I generate a while loop for the Fibonacci sequence. That's worth taking a look at as well. Okay, thanks.